Okay, hello everyone. And thank you for coming to my session. So I'm going to give you an overview today how you can create Android applications which run on every device. And I know this title is very ambitious. So, but I will show you how you can strike a compromise and how you can target as many devices as you possibly can with the type of application you're creating. So a little bit about myself. I'm Christian Kurzke, originally actually not too far from here. I've grown up in Germany, Passau, and I'm now in the Mountain View office. I'm a developer advocate for Android, and the last 6 months I've actually spent working with the Google TV team. You've probably heard about Google TV. Unfortunately, it's not launched in Europe yet, but it's an Android-based platform. It's running Linux, Android on top of it, and it also has a Chrome browser. And right now, we have a couple preloaded applications that have actually been written in Android. And even though there is no official SDK, I've been working with some of the developers, and some of the anecdotes throughout the talk will be from a lot of the work that I've done in this area. So where is Android today? We've seen in the keynote, mobile just in general has been really exploding, and Android in particular. We started 3 years ago with the HTC G1, and since then we have had a lot more devices, and a few of them you can see over in the chill space, anything from like large tablet form factors down to quarter VGA, very small phone devices. And as I've said, Google TV is right around the corner. There will be Android SDKs for Google TV, and for developers, it's a really great opportunity. It's yet another untapped area where people spend 3 or 4 hours a day in front of their TV. It's basically reaching into the living room, and it's a great programming platform. So over the last couple of years, we have gotten more and more diverse hardware. The screen sizes that you see on Android devices range anywhere from 2 inches to 50 inches. And another difference is the pixel density. As you're familiar as developers, a lot of those devices have different displays. Some have more high-resolution displays, others have low-resolution displays. And devices also come with different I/O, different sensors. Most phones today have things like GPS, they have a camera, some have autofocus, others don't. But in the future, especially when we look at devices like Google TV, you will not have some of the sensors. And as my boss yesterday showed off one of the latest prototypes, we have new sensors that are coming in the future to phones. So there is a lot of variety, and I think for developers it's actually very exciting, because you can create an application which uses different hardware sensors, and depending if the device that your application runs on has the sensors or not, I'll show you some tricks how you can at runtime either take advantage of them or fall back to maybe some default implementation. Also, if you've been in earlier talks today with Roman, he talked a lot about user interface design, and I'll show why UI design is also very important when you target multiple devices. Things like different input paradigms. Most phones today have a touch screen. Maybe devices in the future will not have touch screens. Like when I was working with the Google TV applications, we noticed that a lot of developers did not correctly implement the 5-way navigation. Or maybe they implemented 5-way navigation, but still required for some of the functions to use the touch interface. Think about it. If you have, for example, something like a Twitter client where you can scroll through a long list of tweets, and then you have some buttons at the bottom or at the top, maybe reply or retweet. Well, you can't really reach those, because if you're in the list view and you press the 5-way navigation down, you're scrolling through the list view, you'll never get to the buttons. If the user wants to get to the buttons on a phone, they can just tap on the button. On a Google TV, they would have to change from the 5-way navigation to maybe a mouse pad and get to them. So There's some of the things that don't really have anything to do with code, but when you target a large number of devices, you sort of have to keep this in mind already when you design your user interface. So what does it mean as a developer? Well, we've seen the numbers this morning. We have 200,000 activations per day today. There is an enormous number of users, which for you literally translate to customers. Every phone activation is one potential customer that can reach your application. Also, when you look at the lower graph, this is actually from our website. It's on our Android developer website. It shows the distribution of phone versions out in the market. And what I circled here is especially when Android 2.2 Froyo came onto the market, we saw a very steep uptake of Android 2.2 in the devices on the market. So you want to imagine that you launched your application just before Froyo was released. It would be very good for you if your application would run on the next version of Android, because at that point you get a lot more customers and you don't want to have to port your application to a new version. So I'm going to point out a couple areas where you can make sure today that your app is ready for new versions and for new hardware. So looking at all those different versions for a developer, the next question is, well, which one should I actually target? It's very tempting to just say, well, I'm only going to use the least common denominator, and I'm not going to use any of the fancy hardware, I'm not going to use any of the new features, and I just target everything. Well, that maybe means your application is not as exciting. We want you to use the latest and greatest features. There is new devices out there that have really cool hardware, and we really want you to take advantage of it. At the same time, you have to make a conscious decision. Do you want to be on the really cutting edge and support the latest and greatest hardware, or do you want to target the largest number of devices? And in your head, basically keep some curve that says the more features you use, the more you're potentially reducing the number of users who can reach your application. I'm going to show you later, for example, how you can, at runtime, use some of the features when they're available or fall back to a default implementation. There's also some areas, for example, quick search box, which you can support in your code. It's just in XML. You have the configuration files, and it just gets ignored in older phones. So that's one other alternative. So what's the pros and cons? Well, some of them are obvious. When you target a lot of devices, you maximize your number of potential customers. But I also think if you write code that is portable, and if you write code that runs well across different versions of Android, it ultimately leads to better code, which is more maintainable. And I think if you support, for example, 2 or 3 screen sizes, your chances are that it will scale very easily, and you have avoided some of the common mistakes. If you, for example, in your development only test on one device on one screen size, it's very likely that you make some implicit assumptions which will later come back and you have to go back and fix them. The downside, of course, is, like everything, nothing is really for free. If you do the job right, it will be a little bit more work. It will cost you a little bit more time. The question is, does it pay off? So you're all developers, you're graphics designers, as we have learned early this morning, and you're also entrepreneurs. So it's a business decision. Everybody has to decide for their own app how much time do they want to spend versus what do they get back for it. Here is a graph that it's also just on a whiteboard. I'm not claiming any scale here, but one thing to keep in mind when you design your user interface, I keep basically the 3 form factors that people are familiar with: the phone, the tablet, and the desktop. And the way I see the world is the amount of information that a user wants on their device. On a desktop, we're all used to large screens. We want a lot of information. We want huge dashboards. I want as much on the screen as possible. On a phone, just information per square inch is actually also pretty high. You're holding it pretty close, you're looking at it very close up. Small fonts, people want tweet streams, but you're naturally limited by just the size of the device you have. It's tempting then to say, well, maybe I should just have a straight line here and I should just add more information as screens get bigger. What we find is that actually for tablets, people don't really want as much information. If you just take your phone UI and you add 3 or 4 times as much screen space, and you just fill it all up with textual information, the UI looks very cluttered. I mean, of course, it depends on an app. If you have an electronic book, yes, people expect to have a lot of information on it. If you have something like browsing through your media gallery, maybe show larger artwork or use the screen to really show more engaging user interface instead of adding more information. Conversely, also the television set. We actually found that the TV is where people actually really want the least information. Even if you look at a very busy newscast, sometimes you have stock tickers and you have like 2 scrolling bars on the top and the bottom. It's really not that much information. There is a lot of white space, there is a lot of open space, and maybe there is some video playing. When you design an application for TV, you really don't want to keep much information on the screen. Treat it a little bit like a PowerPoint presentation. 3 bullet points, maybe a couple lines of text, no small fonts. The other interesting thing about TV is you actually want to pay attention to the color scheme. We've all gotten used to phones and desktops to have a white background and maybe dark font on it, a little bit like paper. Whereas with television, you don't want like a 50-inch white screen in your living room. It looks really, really wrong. So I'll show that later, but we have found that TV, typically you want more dark and muted backgrounds, muted colors. So let's look at it from a design point of view. I consider this like a typical average desktop application, something like a mail reader where you have your inbox and maybe a couple other mailboxes. You have a list of messages. Maybe you see one of the message details here. You keep most of the information on the screen. People want to have a large overview. They want to like shift their focus from one side to another. They typically sit very close to the monitor. You have very high information density. So what you can do is, when you start with an application, and this could be a web application, I consider web applications sort of desktop. When you break this into a tablet format, or also like a TV format, you would break it up into 2 screens. You have maybe an overview screen, and then when you click on a message, you go into the detail screen. We call this progressive disclosure of information. We don't want to keep too much information at the same time on the screen. And we want to make sure the user has relevant information. When you break it further apart, you get to a format that's maybe suitable for a phone. So here we have 3 different screens. We navigate from one screen to another. And maybe when you press the back button at this point, you go back all the way. So you want to make sure you have the UI broken up into relevant small pieces. And at that point, it also becomes important for you to define what is the navigation path between those screens. I mean, this is a very easy case where I have only 3 screens. A lot of your phone applications will consist of more screens. So I'll show you later, in Android actually, you can have different layout files and you can create different views for the different screens here. I'm sure you've all done that before. So the other thing, just one more last thing to designing your application. Keep in mind how users consume the content on your application. A lot of times when you have mobile applications, people will read the information on the go. They will read it while they're sitting in presentations, like a lot of you are doing right now, I'm sure. Whereas, for example, on a TV, there's 2 different distinct user modes. You have either the background screen where you put on a slideshow and you put on a music player while you're having a party in your house and you're not really watching the TV. and it plays for a while, or you're switching back and forth between TV shows, or you hit an advertisement and you quickly flip open your application. We found that a lot of people do actually the latter. On the TV, the applications have a fairly short life cycle. People want to flip over to an application, for example, check their tweets while there's advertisement on, and then they expect to come back later at the same state. So make sure in your application you keep that in mind, that your application is useful in short bursts, and keep state between the different runs. So here's an example from our Google TV apps. So this is the mobile application. It's a CNBC, it's like financial news application. And there's a mobile app that we used as a basis. And the mobile app, it's very touch screen centric. It has buttons here, it has the list. This was sort of the model for their mobile app, where they have a lot of information on the screen. And then we translated that into a TV application where we reused some of the graphical elements, like the list view here. We changed it from a touch screen user interface to more five-way navigation. So you notice we don't have those little arrows here. You basically can just cycle the focus with your five-way nav. And at the same time, we actually do display the video on the side here. So with the mobile app, when I click on this arrow, it will go and it will display the video for this stock. Here, I can keep both on the screen at the same time. Here's an example for YouTube. So we call the TV experience also the 10-foot UI, or the lean-back experience. People want to sit in their living room, they want to flip through content. So this is the YouTube site, as you're all knowing. You just go to your YouTube web browser, or to YouTube on your web browser. And we've created a 10-foot UI, which has a dark background, and it has a five-way navigation, and it has a very large area to play the video here. So when you design for TV, basically keep the information light, keep it very engaging for the user, and also make sure that it is user-friendly with a five-way navigation. Okay, so much for design stuff. How can you translate this into applications? Well, you want to, as possibly, have one binary for as many devices as possible. So Android gives you a resource framework, and it, for example, allows you. So here, this is a screenshot from a very simple application. It allows you to have resources for different resolutions, and it has layouts for different screen sizes as well. So you can actually create resources for low resolution or high resolution devices, and you can keep them in different directories. When you design for large TV size or tablet size devices, you should keep in mind that the size of bitmaps grows basically by the square of your screen size. So if you have a 1080p image, which is basically almost 2,000 by 1,000 pixels, you're very quickly reaching 5 megabytes or more. So it's important, for example, that you composite your screens out of smaller elements, and you use layouts, you reuse graphical elements. One of the not so good development patterns or design patterns that I've seen is sometimes Android developers, they get a big graphics asset from their designers, and then they put this in the background, and maybe it has really nice swirly graphs, and then they use this background and they overlay information at runtime on top of the background. Well, this assumes that you know how your background scales. And we have seen that a lot of devices now have different aspect ratios. We have, for example, a 4:3 versus a 16:9 aspect ratio. So at that point, when you scale, you may actually slightly distort the graphics image. And what I've seen is one application that I worked with, at first they had a solid background graphic. It was scaled, and it had some highlighted areas. And they tried to, at runtime, position text into this highlighted area. And unfortunately, the text did never really quite match up the background. So that is one of the mistakes that you can easily avoid when you, for example, use layout managers and you create 9 patches that stretch to cover some of the areas. So one other thing that's very tempting is you might say, well, I'll just create graphics assets, or my designers create graphics assets with the highest resolution, and then I just scale down from there. Not just scaling up pixels is a problem, scaling down pixels sometimes also results in some unpredictable graphics artifacts. So here you see an example. I have a very simple bitmap all the way on the left, which is sort of a smiley face that is then rendered into a more low resolution bitmap here. And depending on the algorithm that the system happens to use, you basically get results which resemble the graphics, but they're never a perfect match. It's always preferable to create the bitmaps in the correct resolution. So it's much easier when you start from your design and you have vector graphics that get converted into the proper bitmaps. So this all sounds very complicated, and fortunately, Android has a lot of tools which make your life as a developer much easier. So I hope some of you have been in Roman's talk this morning. He talks a lot about it. He also has a lot of information on his blogs online. Android has a couple really powerful mechanisms. The two that I really want to call out is layouts, dynamically arranging the elements on the screen, and then also 9 patches. 9 patches, when they're used properly, they can look incredibly good on different resolutions, and they use up very, very little space, as opposed to creating, for example, a series of buttons in your graphics tools. And I know it sounds very simple, and I know you probably all know about it, but also make sure that your graphics designers understand what 9 patches are and what they can do. Sometimes they don't really understand what this is, and then they give you large assets. And it's always difficult to reverse engineer a regular graphics asset back into a 9 patch. So it's better to just do it right straight from the beginning. And as Roman said earlier this morning, it's really important, especially for mobile apps or for consumer-facing apps in general, that applications are well designed, very professional looking. So make sure you or your friends know how to do graphics design, and you know how to use the tools. It pays off in the long run. So this is the slide that I think sort of condenses the talk here. Just to summarize, I would really encourage you to use and understand layouts and 9 patches. Make sure you understand how screen layouts get calculated. And then also use, of course, density independent sizes and measurements in your layouts. What I'm going to talk about next is some of the device dependencies in terms of sensors. Then I'll give you a little bit more information about how you can use reflection, which is a standard Java language feature, to resolve the API dependencies at runtime. And I'll show you a couple new features in the Android SDK that allow you to reuse code across different Android APKs. Lastly, one other anecdotal evidence is I encourage you, even as a developer, to maybe take a look at the Android compatibility definition document. Typically, this document is most interesting for hardware manufacturers. It basically tells people what a device has to conform to be called Android compliant or Android certified device. It can be actually a really interesting read for developers. One anecdotal story is when Android was new and early, a lot of people had the HTC G1. And the G1 has a notification LED that can have different color settings. And there was a couple of developers, for example, who had Twitter applications that use different colors if you have a direct message, or if you have a mention, or if you have new tweets. And it works great on the G1, except the CDD never specified that the LED should have more than one color. So a couple months later, new phones came out, and the newer phones, for whatever reasons, had only a black or white LED. And then people commented in the feedback of those applications that the application is broke and it doesn't run on, in this case it was, I think it was a Motorola Click phone, doesn't run on the Click and whatever. Well, it was not the developer's fault, and it was also not the manufacturer's fault. It was just that the developers relied on sort of an undocumented feature in the hardware. So take a look at the CDD. When you use some of the features, make sure you're actually relying on something that is part of the standard and that we also test when we certify new devices. Okay, so not relying on implicit assumptions. You all know the Android manifest. It is sometimes an unwieldy, long XML file, and the last thing you want to do is add more information to this XML file. Here is a reason why you should. So today, most devices, for example, have a camera. A lot of them have autofocus. And in the past, this was not really an option. So as new features were added, sometimes applications or the Android market made some implicit assumptions just to basically make sure that older applications that didn't know about those features run on the new devices. So what does that mean? That means that when you in your application use hardware features or use sensors or any of the other things, I'll give you a list in a second, make sure you either define that you really, really need this if your application cannot run without it. It would not make a lot of sense to have a, say, photo sharing app which doesn't have access to the camera. But make also sure that the other features which you use but which are optional, that you actually specify that they're not required. Because otherwise, the frameworks and the market may actually assume that your application must have those features on the hardware and it will not run without it. So one example is if you, for example, use camera APIs, by default, the framework assumes that you also need autofocus. If you specify that you do not need autofocus, you say required equals false, then your application will run on all devices with a camera, regardless if they have autofocus or not. And you can then, at runtime, inquire from the platform. If this specific device has autofocus, you can use it. If it does not have autofocus, well, you just ignore it and you assume the hardware does the right thing. And note, this is different from permissions, because the very simple reason you can specify that you, for example, want the say, camera permission, but you do not necessarily require the hardware. So that if a device has a camera, you can use it, you have the permissions from the install, but your application can also execute on a device which does not have any camera at all, which, for example, in the future will be Google TV. If you want to write an application, say a Twitter client, which can take photos, but it's not really required for execution, you should specify required false. So in the future, when Google TV becomes available with Market, your application can actually run on those devices. So here is an overview of some of the features which are currently in Android 2.2, which are available to you. And it's anything from things like camera to location, different classes of location, the microphone, which, of course, again, on a Google TV, you will not have any of those devices here. It doesn't make sense to have a compass in your TV. Nobody's going to start moving around their television. So this is a really interesting feature, and you should use this in the manifest. I really encourage you to look it up. There is more information in the package manager class. So currently, there is a blog post about this, but there is not a whole lot of information. So check out the package manager class documentation and some of the blogs that are available on the Android side. Okay, so now let's assume you have said, okay, my app can run without this feature. I don't need it, but it's nice to have when it's there at runtime. So at runtime, you can use the package manager, and you can call the has system feature method, and you pass in the name of a feature, and it will return to you whether this feature is available or not. It's then up to you to implement some fallbacks, maybe make some options available conditional to the result here, or just have default implementations. So the other thing that you can do to make your application more useful across devices is creating components which are optional. And I just mentioned this briefly here. Some of the devices, for example, they use, or we still have devices out there that run on Android 1.5 or 1.6, which don't have things like search providers, or the older versions don't have home screen widgets. Make sure your application is able to run without those. It's nice to have widgets, but if widgets are not available on the platform, don't rely on them. Okay, so now earlier we have seen how to take advantage of features. Now I'm going to show you a couple more concepts, how to take advantage of new APIs and new hardware. So as devices have added more hardware features. So for example, what I'm going to use here is the multi-touch touch screen on devices. Almost all new devices now have multi-touch. Some older devices do not support multi-touch. And so there was some APIs added to the Android classes to support this. It would be really great if your application, for example, can run on both Android 2.2, which supports those methods, and maybe older versions of Android, which do not support this. So what has happened is, in the class Android.view.velocityTracker, which has been around since the beginning, we always had a method, for example, getXVelocity, and the same for getYVelocity, which returns the speed with which a user, for example, is touching or is moving the pointer across the screen. So in Android 2.2, we have expanded this, and we have also added a getXVelocity, which now takes a parameter for a pointer ID. So this can be useful if you want to track the speed of 2 or more fingers on the screen. Maybe you're writing a game that needs to know how fast you're moving 2 fingers across the screen. If you don't care about 2 fingers or 2 pointers, you can still use the old method. If you do care about the new method, what you would have to do is you have to compile against the Android Froyo SDK, which has those methods, and then you can call into this method. You also have to specify in your manifest that you require Android 2.2, which limits you to the about 30% devices right now which run Android 2.2. If there was a way to do this without declaring that you require the new SDK, you could reach the other 70% devices, and maybe you would lose only very small functionality on those devices. So how can you do that? Well, if you just compile against it and you set a lower minimum SDK version in your manifest, you will get runtime errors. You will get forced close, whatever. So what you can do is you can use an Java language feature called reflection. And this allows you to call the method dynamically at runtime, and you can still work on older devices. So a little bit, so this code should be familiar to you. This is standard Java reflection. What I do here is I basically set a default value, and then I try to get the method of velocity tracker. So I get the velocity tracker class, and then I look up the method with the name getXVelocity, which takes an integer class as a parameter. If that works, if it doesn't work, I just fall here into the catch case. If it works, I will invoke the method on my tracker object with the pointer ID. If that gives me a reasonable value, I use this value. Otherwise, I fall back to the default. So this looks like a great idea. This is standard Java, has been around for 10 years. Most developers should be familiar with this. The problem is, this is actually a bad idea. You may have heard Dan mention that earlier. Dalvik and Android has a lot of features to optimize the bytecode. It has just-in-time compilation. Anytime you do something like this, where you dynamically look up methods and you call methods, it does work, but it's really slow. So if you do this in an event handler, if you do this in an event handler, or if you do this in a tight loop where it's done over and over again, you will get very poor performance. So you should not do that. So as I said, this is basically what I just showed you. It defeats the purpose of the just-in-time compilation. It will be anywhere between 10 times to 100 times slower than a regular method call. So what's a better way to do this? Well, the ideal way to handle this is you want to make the method call as native as possible, and you don't want to do dynamic reflection every single time. So even if you just look up the method once, what I showed you is basically the worst case. You look up the method and you invoke the method dynamically. But even if you look it up once and then you invoke it, you still have a performance overhead. So the way we recommend you doing this, and there are several examples. If you look, again, on our blogs, there's actually a blog about backward compatibility for Android. And there's also a recent example which, when you download the Android SDK, it comes with a bunch of examples. Check out the contacts example. It uses this. There was a change in the contacts API around Android. I think it was 2.01. So the way we recommend you doing it is you actually implement two different classes. You implement roughly one class which has the old functionality, one class which has the new functionality, and then you dynamically instantiate whichever class. So the way this looks like is it's using something called the factory pattern. So you would have an abstract class which defines the API of what you want to do. So this would be a couple more methods than the one I just pointed out here. So in my example here, I have a pointer tracker class. I called it my pointer tracker. It's an abstract class, and it would define some abstract methods for things I want to do, like track my pointer. It would also have a static method, which is getInstance. And so I would implement this in the abstract class, and I would query the SDK version. I would compare the SDK version with whichever threshold I need for this API. And then I would, at runtime, instantiate the simple pointer tracker or the cool pointer tracker. And those two classes implement this abstract class, or they extend the abstract class. And one of them uses only, for example, donut features. The other one uses froyo features. So this is very high level how this works. And you only incur the dynamic reflection overhead this one time when you do the get instance. One thing I want to point out is I did not just do a new class or a new, because if you do new, then actually the precompiler will have to make sure those classes are available, or it will pre-verify those classes when you load the class in. You have like a static dependency on those classes, which would actually throw a exception. So the way you want to do it is you want to use class for name to instantiate the class to give you a decoupled dependency here. And once you have incurred this once, so you would, for example, instantiate this in the very beginning when your app initializes. After this, you will call directly in this class the method that you have defined. So in this example, I would have a method, for example, track, where I pass in something and it performs just as fast as any native Dalvik method invocation. So this is actually a pretty useful pattern. And you can use this not only for the use case that I used it here, where I have different SDK versions. Another use case where you can do this is if you, for example, have a demo version versus a full version, or maybe a light version versus a paid version, and so on. So the abstract factory pattern is pretty powerful, and it's actually something, it's actually fun. The one downside I want to mention is, especially when you play around with different SDK versions, make sure you really test that. Because if by accident you pick the wrong SDK version here, bad things happen, class not found exceptions, method not found exceptions. You want to make sure you really, when you do tricks like this, make sure you test them. Okay, so I've shown you a lot of tricks and a lot of difficult things you can do to create one binary to support multiple versions. Well, what if you have actually decided, nah, this is all too much. I actually do want to create multiple binaries. Well, we have something to make your life easier too. So again, this could be used for either supporting different versions of hardware, or you could have free versions, full versions. There's a couple of ways you can do this. So the old-fashioned way, which still works really well, is you can have your shared code in a jar file. And this could be, for example, libraries. So if you have a backend server and you want to encapsulate the communication with your backend in a jar file, that's a very good way to do this. Or maybe you have third-party utilities that you can pull in. Use a jar file. Android, the Eclipse IDE, or also the command line tools, you can have dependencies on jar files. They will be pulled in and they will be basically converted to Dalvik files and packaged in your APK. The downside with this is this works great for Java code. This does not know anything about Android assets or Android resources, layouts, and so on. So if you want to share more Android-specific stuff across APKs, we need to have more advanced and a little bit smarter ways to do that. So the new SDK that came out this summer with Froyo, it actually has a concept called libraries. And I want to highlight this is not only a cool thing for Froyo, but this also works across all different versions of Android. This is purely a build utility. This is not tied to a version of Android. So you can create APKs for older versions of Android using the same concept. And this works with the command line tools as well as with the Eclipse IDE. So the cool thing about libraries is you can have library projects which contain Java code and Android assets. So you can, for example, have layouts, or you can have resources in your library, and then you can have either additional resources in each of the Android APK projects, or you can actually even overlay assets and resources which were defined in your library. Another actually interesting use case is if you want to internationalize your application. Android already gives you a lot of ways to have different languages supported in one application. But if for some reason, for example, you, I don't know, want to choose different graphics assets for different languages, maybe it's worthwhile, if it gets too big, to have everything in one APK, to split it up. And if there is a new version in your application, it will overwrite, or it will overshadow the library version. If there is no new version, it will fall back to the library version. And you probably all know the auto-generated R dot class, which gets generated by the Android SDK. So it will result in one r.dot class, which references both the resources in the library and the resources in your application project. And the IDE will package it together and will resolve this at runtime, at build time. So here's an example of what it looks like in your IDE. So this is just a screenshot from Eclipse, and you would go to your Android project properties, and you can either check the is library, or you can define dependencies on libraries here. And then in your project, you would have the library basically merged in with your regular project. Okay, so in summary, what we really encourage you to do is take advantage of the devices out there, take advantage of the different devices that are available, and try to make a conscious decision for your application, which software versions you want to support and which features you want to support. I really want you to remember when you go home that user interface design is first of all, it's very important, and it also gives you a way to differentiate. I mean, if you have a great looking app on a new form factor that comes out, your app will definitely stand out. And so it's really an opportunity to shine. And then in Android, you have a lot of different mechanisms. Make sure you know about them and make sure you use them. And also, if you have, for example, contractors or UI design agencies, make sure they understand. And if they just give you one big Photoshop asset, just push back and ask for 9 patches and explain to them what you really need. And Android lets you support different hardware families and different platform versions. And using reflection, using library projects, you can either target multiple versions with one binary, or you can conveniently split your app into multiple binaries. Okay, so if you have any more questions, I encourage you, first of all, you can ask me now, you can ask me later. Give us feedback using the mobile app. By now, you should all have scanned this barcode at least once. We also encourage you, as said, to tweet either on Twitter, use the GDDCZ tag, or you can find me directly on C and Kurzke. I occasionally tweet something useful about Google TV and Android in general. So again, thank you very much for stopping by, and I really hope that with this information, your applications will differentiate and they will really stand out and support new hardware as well as the largest amount of existing devices out there in the market. So with that, yes?
Is there any easy way how to run emulator configure to match some specific device? Like emulate the use scenario of Jiva or Exusa or whatever, like some predefined configurations of emulator?
So the question is there predefined profiles or predefined configurations for the emulator so that a developer can just choose, okay, run for Nexus 1, run for Motorola Droid? Right now, no. So basically, as a developer, you have to know what's the screen size, what's the SDK version. Also because, especially for a lot of the hardware, there is different updates, there's different versions. So we really encourage you to test amongst a large subsection of devices. So just create a couple permutations of small screens, large screens, different aspect ratios. I think ultimately what you should take advantage of is also in the Android market, there is a pretty good feedback mechanism. So once you have your application deployed, you will see if there is any problems out there. Of course, you should catch them earlier, but if there's any crashes or any stack traces, you get back an information of what SDK level this device was running, what hardware it was. So that information plus the emulator should give you an opportunity to reproduce this at home, hopefully. Yes?
Back to the
Mm-hmm.
There is no way I can call in this advanced class this new method from the new version. So I didn't really know.
Okay, so the question is, when you specify in the manifest, for example, Android 2.2, in this example here, you specify Android 2.1, which is a version which does not have this new method. How can you call this new method in the API or dynamically at runtime? So that's where, first of all, I want to remark that's where the testing comes in. But what you can do is you can, in the IDE, you can compile against the API level for Android 2.2. And then you still set the minimum required to 2.1. If you don't do anything else, this is a bad thing and your application will crash. And that's why I recommended the factory pattern. If you do it right and you test it, it should actually work.
I wasn't aware about those tools.
Yeah.
There's a difference between what is compiled against and what is the minimum.
You will get warnings in the IDE, but those warnings mean, yes, I know what I'm doing. So check out the contacts API. So there is, in the samples, it's slightly different. They don't use the factory pattern. They actually use reflection directly. But it shows how they use the old API and the new API in the same application. Any other questions? Okay, one more.
Very, very smart question. It's just part of my knowledge. I didn't know about libraries.
Mm-hmm.
That's the part of Eclipse plugin. I can create Android library project and use.
Yes, so the question was about Android libraries. So if you install the latest version of the development tools, I actually didn't write down which version it is, but whatever is current out now, you can create an Android project, and then you can go into the project properties, and you can check the box that says, is Android library? And you cannot compile a library into an APK, but you can then include the library. You can define a new project, and you can, again, go to Android properties, device project properties, and then you can say, okay, this depends on this library, and then it will merge the two projects in at build time. And this works in Eclipse, but this works also from the command line tools. Okay, one more. The libraries are really only a build concept, so no, there is no such thing as basically a deployed library or a compiled library. Mm-hmm. It's an interesting thought. I don't think we really have any place where you can share this. If you, for example, want to create an open source project around your library, that would be one way. So check out code.google.com and create a library project. I think it's an interesting thought. I haven't really considered that as a deployment or like a collaboration unit. Okay, so I think got to wrap up. We have another interesting session coming up in a few minutes here. We'll have Rito and I don't know, talk about HTML5 and native Android development. So hope you had a good day today already, and find me. I'll be outside. I'll be walking around. Thank you.